last point, and then we are going to do control, okay? How do we compute a transition metric for non-diagonalizable systems, okay? At this point, what do we have? We have something that is non-diagonalizable, together that it's not non-diagonalizable, perfect. And somehow, this is the prototypical situation where we have non-diagonalizability, true? Now, look at the system here. If I have a system that is this one, and I have an initial condition that looks like this one, I go exciting only the first one. I go selecting only this stuff. This is 0 because of these ones, and I get something that somehow is like the diagonalizability term. True? Do you see it, people? Perfect. But in general, if I've got this stuff here, what happens? It happens that this one goes exciting x3, but then we have kind of a percolation. So this one is meaningful because x3 doesn't depend on the others, but the other ones will depend. True? In a certain sense, x3 will enter here, and x2 will enter here. I can't expect to have this for x1 again. There's a term that is an additional term that is going to force. Do you see it, people? Perfect. Okay. System D, system J. System D, we know evolution. From this means evolution, evolution. From this, we have, if we were starting here, we would have an evolution. If we were starting here, we kind of have an evolution on one axis, but the other axis is influenced by the other axis. They are not independent. Are we together that they are not independent anymore? Perfect. Okay, let's go here. So, towards matrix exponentials from numerical points of view. Let's take a Jordan mini block, and let's write the Jordan mini block in this way. The lambdas and this that is the super diagonal of ones. For example, 0, 1, 0, 0, 0, 1, 0, 0, 0. Do you see it? This one generalized at this one. It's like putting zeros here. Are we together that we have that this is diagonal plus super zeros, super ones? Together? Perfect. Now, didn't we say that whenever we have this object, we have this object, or better, we have E star plus square is going to be E of star times E of square. True? Doesn't it mean that if I've got the Jordan mini block that is diagonal part, super ones, I put them here, I will have E diagonal part, E of super parts? But then, this one we know it. True? Are we together? The lambda is the same. The lambda is the same. So if I was having zeros here, here we would have E lambda t, E lambda t. At this point, it's E lambda t identity. Are we together, people? This one, you saw it already twice, I think. 2, 3 times we saw it. If I have 0, 1, 0, 0, 0, 1, 0, 0, 0, we have identity, the stuff with t. This one is going to be, and then disappears. True? We saw it. And whenever we go higher order, if we were having this one would be this one, this one would be this one, and this one would be 0, 0, 0, 1, 0, 0, 0, 0, and no zeros. True? And to the power of n of power 4, all zeros. Together? Then at this point, this happens. Read it, think about it. 1 minute. Look at the structure. Let's make an example. Let's make an exercise. I've got this n, that is of dimension of n is 5. So this is 5 times 5. Okay? In the upper corner of E and T, what will I find? Go, discuss and find. It's gonna be t to the power of something. What is this something with the fingers? 4, true? Divided by 4 factorial. Okay? So essentially, we will have, given a dimension, this one will have a dimension minus 1, dimension minus 1, and this is going to be dimension minus 1 factorial. Okay? Together, perfect. At this point, if we have this one is this one, then it means that I've got that E, this one is going to be E lambda I, E lambda T times I times E n T. True? This one is this one. This one is this one. Are we together, people? And if we multiply those two matrices here, this I is not here. We can also leave it there, but it doesn't matter. And here it is. Again, exercise. I've got a Jordan block associated to the eigenvalue lambda equals to -2 and of dimension equals to 4. Find this one. Go. Write it down. Lambda is -2 and the dimension of the Jordan mini block is 4. The 1, 2, 3, this element here is going to be E minus 2t, t to the power of 1, 2, divided 2 factorial. Together? How much are we together, people? 1, 2, 3. This is very procedural, but you see the point. Excellent. And at this point, if I have a block diagonal matrix and I've got E block diagonal T, this one is going to be block diagonal, true? Do you see that this has to be? They are independent subsystems. Each subsystem will evolve independently, and this means that we will have this is going to be E that Jordan block, this E that Jordan block, this E that Jordan block, this E that Jordan block. Do you see it, people? 1, 2, 3. Okay. Now, you tell me. This one. Go. How does X4 evolve? What does it mean? What does X4 evolve? This question means, how does it look? The fourth column of E, A, T. This is a matrix, true? Column. The fourth column. How does it look like? Go, do it. I don't see so many people. Uh, I got it. I would have gotten it. I was lost. Why I see many? I was lost. I see many. I was lost. Let's do it from a practical perspective. This one, this matrix has this block diagonal matrix structure. Are we together on this? Are we together on the block diagonal? Perfect. If I do E d stuff t, it's like having E d stuff t, E d stuff t, E d stuff t, E d stuff t. True? And all the rest will stay zero. True? Question. If it is what? Yeah, I'm dumb. Yeah, sorry. I was looking at the fifth column. My mistake. I was. This is the solution for the fifth column. You see that it's a fifth column. Okay, sorry, but let's redo the steps anyway. This block diagonal structure means that EAT will have the same block diagonal structure. Every block will be EJT. If I look at this block here will have the structure of E minus I plus n of dimension 4 T. True? Together? And this one, if we look at it, the fourth column will be this one. Are we together, people? 1, 2, 3. I see puzzle faces, but I don't know if they. Question? The fifth column, this column here, is this column here. If I was taking the first column, what would I get? I would get E minus T, 0, 0. Okay? Perfect. Now, if I go back to this one, in a certain sense, the intuition that you should have is that this one, 3, 4, 5, 6, how many? 7, 8. This object here, or better, this object here, sorry, it's this one. This object here is something that for t equal to 0 is somewhere in this 8-dimensional space. True? And then if I look at it, how it evolves for t, it will stay in a 2-dimensional space generated by basically those two elements. True? And it will do something that looks like a decaying to 0, because this one will decay to 0 and this one will decay to 0 and this one will decay to 0. The two components that are not 0 will decay to 0. As a column, it goes to 0. Together? Do you see it, people? 1, 2, 3. Do you see it? But it lives in that subspace. And the interesting thing is this one. If I start in this column will evolve along 1 dimension. If I start with this column will live in 2 dimensions. This column here will live in 3 dimensions. This column here will live in 4 dimensions. Do you see it? E minus t, 0, 0, 0. Then I will have e minus t, t squared, 2, e minus t, t, e minus t, 0, e minus t, t cubed, 3 factorial, e minus 2t, minus t, t squared, 2, e minus t, t, e minus t. Do you see that this one is this one? And it's an evolution along 1 dimension. This one corresponds to an evolution along 2 dimensions. This one corresponds 3 dimensions. This one, all the dimensions of the Jordan mini block. Okay, together. In a certain sense, this is along a line, this is along a space, 2-dimensional, these along spaces that are 3 and 4 dimensional. What is happening here? In a certain sense, there's a curvature included in the evolution. You see it? Let's make another example. I think that 0, 1, 0, 0 was giving 1, 0, t1, true? And then we were having that this object here was staying here all the time. And this object here was moving around, true? Do you see that there's an object that is moving around? This object stays in 1 dimension. This object spans 2 dimensions. Are we together, people? Do you see? 1, 2, 3. Read this and tell me whether it's the same stuff as before or not. It's the same stuff as before. Not, it's different, but serious differences, or the same or practically the same. Very big differences. You do not know whether there's differences or not with respect to D. J and D, how different are they? What do you think, people? Where are we? It's the same, true? The same. And that also, what happens whenever I do EJT, this is, or better, EAT with A non-diagonalizable. This is going to be equal to T EJT, T minus 1. Okay? Perfect. The spring mass system as before. We have that this is our evolution. We saw it a few times. And I think now we do something. And we do a self-reflection. You came inside this course knowing that this is a matrix, true? And you were thinking that the matrix is nice, it's kind of a strange collection of numbers. I might associate some funny things like, I don't know, some eigenvalues and eigenvectors. Very interesting stuff, very Sudoku-like things. This one is a system with its structure, with its Jordan blocks and mini blocks. This stuff here tells you how a system evolves. It's not a collection of numbers. It's a description of reality. Might be wrong, of course, but it's something that works as a description, and the Jordan structure of this object here tells us a lot about this object here plus sorry, yeah, 8. Okay, are we together? Hmm? Are there questions, people? With this one, with this slide, we finish the linear algebra, and I think at this point next week we go to control. How are we, people? Hmm? Those ones, where do they originate from? Okay, perfect. Next week will be the last week where we do stuff, we do control, and we basically connect this object here, this object here, with Laplace in a more precise way that we will see. Whenever we do state space control, you will see how we saw stuff and it's the complete picture, but somehow, sometimes, whenever we do x dot is equal to ax plus bu, y is equal to cx, the roles of those two are going to be very instrumental for understanding how the input-output relation is going to be. Okay? Perfect. Let's stop here.